Welcome to Projects from the Bottom Drawer. My name is Brian, and you can find us at wearboard.com/projects or bottomdrawerprojects.com. What I have on the bench today is a Silvertone Powermaster. It claims to be a model 634 battery tester. Silvertone, of course, was the house brand of Sears and Roebuck. And at one time, Sears sold radios, radio parts, radio kits, and associated electronics for the early radio era. They were pretty much the store that sold everything at one time. And as the times changed, their lineup of merchandise changed until they changed right out of business, unfortunately. So this is kind of an interesting device. It looks like it was designed to sit on a bench, not necessarily a bench, perhaps a counter in the radio department where customers could bring their batteries in and test them. It goes anywhere from 1.5 to 135 volts with all of the common B and C batteries, as well as A batteries in there. It also has this adapter for a 5-pin connector. I know I've seen this before. I believe this was on certain multi-voltage batteries, but I can't tell you what the name of that is or even what kind of battery that was. I just know I've seen it before. This device looks like it probably had test leads that came out at one time, and the probes would have went here. Those are unfortunately long gone. They were gone when I got the device at Findlay Hamfest 2024. Was that 2024? No, that was 2025 when I bought this. I'd seen it in 2024, didn't buy it. And when I saw it in 2025, I made the guy an offer of a few bucks. Hey, whatever, take it home. It's a neat piece of equipment, especially if it works. So I've already taken out the screws. And let's just lift this device out gently. I don't know what's, okay. Let's set the cabinet aside. It's pretty simple inside. Your connector, there's a fuse for the meter that just flies off into space. Looks like a range switch, a little terminal board, and a bunch of IRC resistors, old ones. I mean, these are 1-watt resistors these days. Those would be a fraction of the size. So those are probably all old carbon devices. Except for this one. That one's kind of cool. It's like almost a metallic dog bone with a ridged surface. I don't know if that's intentional, maybe to dissipate a little more heat, which seems unlikely, or if that was just the manufacturing process. Yeah, most likely that was just the manufacturing process. But let's see. What's kind of neat is it looks like all of these little resistor pairs were probably hand selected, and on them there's tape with a value written on it, which is really cool. So where would inputs have been? Let's see. Actually, that little terminal back there looks suspicious. Hold on. Let's see. I would say that was probably an input. That looks like that's had something removed from it at some point. I don't know if the camera will see it or not, but this terminal right here definitely looks like something was pulled off of it at some point. Let's see. So that's the input to the range switch, and that's got a weird double deck piece of phenolic on it. So yeah, I'm going to guess that's positive. Let's see, where would negative be? So this is probably the positive lead, this fused portion. Negative goes to the meter, to the here, and then it also goes to, looks like this big junction, this big knot of wires here. So that, since that goes directly to one side of the meter, I'm guessing that's the negative side, is this here, and not sure what the rest of this stuff is, maybe just protection, as it looks like these sets of resistors, everything goes through. So I have a C cell here. I've tested this under no load. It reads about 1.56 volts. So it's a strong cell. At least it's putting out its full rated voltage. So let me make some janky adapters here. And we'll test this thing out and see if it works. Unfortunately, I don't have any other types of batteries. I mean, I could probably come up with a 3-volt cell. And if I really wanted to, I'll bet there's some lantern batteries floating around out there somewhere. But yeah, those are expensive just to test with. So let's see. Let's clamp, whatever we want to do with this, clip our negative on there. Let's get our positive on there. Just make sure. Yeah, that has to be the positive. I mean, that there's a bunch of wires flying off of that connection that go everywhere. All right, so let's see. I'm going to grab a piece of paper towel here as an insulator. And then we'll just use our power box here as a stand. Can you see that? Not very well. All right, device, stand up. All right, there we go. Let's get some light here. And you should be able to see the meter deflect if it works. So let me turn that up to about 6, and we'll just see if we see any meter activity here. Oh, we do. Awesome. And it's in the correct direction too, which is always a score. So let's see what we've got. Useful battery, about a little bit under 90% according to this meter. Well, that's pretty cool. It does seem to work. And actually, let's just try something here. We'll just take Mr. Power Supply, set it to 3 volts. Since in reality, this is just a voltmeter, a very poor one, but okay, good. Let's go to 6 volts. Actually, 4.5. Interesting battery size. Can I get 4.5 reliably on this thing? Probably right there. Well, that is very cool. Let's go to 6. No dampening on that meter at all. And let's see, what can I get the most? 22.5. So I have no idea what the output is on this full range power supply. And it's obviously not 22.5 because it says that that is now depleted or getting towards depletion. So very cool. This device works. I don't know what I would use it for, but it does work. It's cool. It's definitely a relic of a time past. I mean, I suppose it probably, puts the battery under a little bit of load and gives it a test. What more do you need? You put a load on it, battery's good or bad. So the only thing I would question is how reliable is the device as far as accurately reporting those batteries. Because if you're not familiar with this kind of equipment, you used to see big tube testers in every drugstore, every Kmart, every kind of store that could have one. Sometimes even groceries had one. Just a big cabinet full of tubes and a tester where you could put your tube in a predetermined socket. Those generally reported weak, even if you had a good tube. You could probably pull one out of the stock that was there at the cabinet, put it in, and have it say, yeah, this tube is about half of its useful life. And that was because they wanted to sell you new tubes. So they deliberately turned down the readings to make everything look bad. And of course, Sears would want to sell you batteries too. So, did they turn this thing down a little bit so, even a good battery would read bad? This cell seems to indicate no, which is interesting. Maybe this was before they really decided to shyster all the money they could out of their customers. But who knows? So what I'm going to do is pull the knob off. Probably, can I do that? I don't think I can get this connector out without damaging it because it's got a push-on washer on the back. I'm not going to try with that old plastic. But I might just loosen this up and pull it out a little bit and clean around the device on the front panel. Just try and make it look a little nicer. Probably clean the cabinet up. And definitely we'll be putting some sort of probe or maybe even jacks here, depending on what I have and what fits in that hole, because I don't want to drill it out. But I do want to have something on it where we can use it. All right, let's get the clip leads off here. Put our insulator back. Oh, there's my other orange stick. We'll put our power box back there. Put the rest of our ICO 950 parts back there out of the way. There you go. The Silvertone Powermaster Model 634 battery tester does seem to work. A little bit of cleanup and some new leads, and we can use this for, I don't know, testing batteries that we don't have. Anyway, this will eventually show up on my project page, cleaned up, of course, and you can check it out there. So thank you for joining me. You can find us at wearboard.com/projects, where you will find this device and many others I've worked on.